Hi to one and all. Welcome to R sessions. In previous R sessions, we discussed about introduction of R programming, and we discussed about the differences between R and Python, and we discussed about the statistical developments using R, and we discussed about features, applications, and characteristics of Python. So these are the things we have discussed in our previous session. Now in this session, we discuss about R sessions. So in these R sessions, we'll discuss about how to install the R, and we will discuss any one environment that that works with R, and we will see R sessions, and we will see the first program in R. So myself, K. Ram Mohan Rao, we are going with R programming. So today's we'll discuss whenever we want to install the R. So we'll discuss what are the system requirements and how to download the R programming. Once we download that software, what are the steps we need to follow to install that R, and what are the common issues we are facing while installing the software. So here we are going to install R, and we will see R sessions, and after that we will write a simple program and we will execute it. So, and lastly we will close this session with the conclusion. So system requirements. So whenever we install the software, so before installing the software, our systems expect some requirements. So here the requirements are operating system. So the operating system might be anything: Windows, Mac OS, and Linux. And moreover, our program is software compatible. I mean, it can execute it in every operating system. So whether it is Windows, it will be fine, Mac or Linux, and it requires 2 GB is the minimum RAM. So in order to work with the R environment, our system has to be 2 GB or more than that, and free disk space is your wish, but it's better to have 2 GB or more, and processor, it will be 1 GHz or more. And please note that these are the minimum requirements, and you may need higher specifications depending upon the size and complexity of your data sets. And we know that why we are using R, in the sense, in order to perform the statistical analysis, in order to perform the statistical computation. So it depends upon your requirement. We can increase the system requirements, but these are the requirements that are minimum to install a R and perform some basics of statistical computing. So in order to perform more complex statistical computing operation, we require more requirements. So it is also recommended to have high-speed internet connection for downloading additional packages and updates. And we know that R is a ocean of packages, right? So in order to upload, or in order to plug in more in packages and modules, we better have more internet speed. So these are the common requirements for using the or working with environment, along with some moderate internet speed. So how to download? In previous session we discussed where we will get R programming software. So R program can be available in both R Consortium as well as CRAN. So from those two platforms we will download our R software. So to download R programming, go to the official website and click on the download R link. So here the official website is nothing but R Consortium, www.r.org. So choose your operating system and then select a nearby mirror site download form. So here we need to discuss about this mirror site. So mirror site is nothing but it leads us to a place where we are able to get our software, and at that software will come up with different versions. For example, if I am using the Windows and my system supports 32-bit, so it will give us the 32-bit version of the operating system. If it is 64, then it will get 64. So if it is Mac, or it is a Linux, or it is a Unix, so the different versions of the software will be available there. So it leads us to that place, and from there we will download the software what we want. So once download is complete, run the installer and follow the prompts to install R programming in your computer. So here we are downloading the R from the CRAN. So in previous class only we discussed, so if there is any software or if there is any package that is not available in r.project r.org, that can be available in CRAN. So in this session we will see what is CRAN, but in previous session we discussed that if any package that is not available in the R consortium, those can also be available in CRAN. So here we give a link that is from CRAN. So what is CRAN? So CRAN means it gives a full name for Comprehensive Archive Network. So Comprehensive Archive Network will provide binary files and follow the installation instructions and accepting all defaults. So this Comprehensive Archive Network will give all the packages or modules can be downloaded along with the software. So along with CRAN, we also have an RStudio. Actually, RStudio is an integrated development environment that supports to execute or to write the files and execute the R programs. So basically, this RStudio usually comes with four windows. So the first window will be the console. So RStudio, this RStudio is used to come with 4 windows like this. Actually it is an IDE, integrated develop environment, where we can write the files and we can execute the files and we can also save the files in this RStudio. So we discussed it has 4 windows. Like first window will be console, second window workspace, third window for files, packages, and fourth window will be the plots. So like this we will have 4 windows in RStudio. So this is the console and this is the workspace. Okay, in the console it is a terminal where we can execute, or once we write the file in this workspace, we can execute that files in this console. So workspace is the space where we will write our programs, we will store our programs, and once any file is saved, that file can be opened and this file can be executed in this console. And basically console, it used to come with different environments. For example, if you wanted to Python console, it will comes with Python. If you want to use the R, it will be R. So this RStudio is also a cross platform. It can support multiple environments, whether it is R, whether it is Python, it can support multiples. And comes to the files and packages, if I wanted to install any files, or whenever we want to write any operations on the files, or if you want to install any new packages, so all these things will be available in this third window. And last one is plots. So whenever we want to design any new plots, we will use the plot functions. So in order to plug in those plots, we will plug those plots from this fourth window. So these are the 4 windows of this RStudio, so which are mostly supported by this R programming. So CRAN and RStudio, they plays a vital role in R programming to execute, to perform main task. So this is about CRAN and RStudio. So now we will see, what we are doing with this. We have been discussed so far. Now we see what are the different steps that exist in the installation of R programming. So to install R programming, first we need to download the software, and after that the file can be will automatically stored in the downloads file. We will move that file into the C drive. So why we are saving in the C drive? In the sense, whenever we are changing the OS, better it will store the files in the C. So we will store our download software in the C drive. So the first step is this is how we are download. This is the mirror site. So from this we will download. For example, I am using the Windows. From this I'm download by clicking this link. We will set up the installation process. So when we click download 3.6.4 for Windows, our downloading will be started off down our setup. Once the downloading is finished, we have to run the setup of R. So once we have done, it will ask what bit version we are having. So see here, we are having core files, 32-bit files, 64 files and message transactions. Among this, we will select which components should be installed. So here I am selecting all. Then after we need to click next. So in the next step we have to select either customized startup or accept the default. So it's better if you are not familiar with R, you better go with default setup. Okay, so if you are going with the default setup, it will be good. So if you wanted the customized setup, then you need to click more options in it. So it's like for an AVI user, it will be better to choose the default setup for the software. So once you clicked on it, so our installation R will be done. So basically R software installation and Python installation will be the same. So if you are okay with the default setup, you just click next to next, that's it. So if you are click on 4 next, your installation will be done and your environment will be set up. So once the installation is done, it will give completion of the installation dialog box like this. You click finish and after that you start your work with the software. So this is the 4 steps that lies when you are going with the installation of R. Now we will see what are the common issues in this installation. So installation errors due to the missing dependencies or outdated packages. So before we need to check whether our operating system supports 32-bit or 64-bit. Depends upon that we need to install the software. For example, if your system is and more thing, so if your depends upon your type of the operating system, we need to choose the download version. We need to download the software. So ensure that all required dependencies are installed before attempting to install R. So previously we discussed some requirements, whether those requirements are is available or not. So first we need to check that. After that we need to start the installation and regularly updated packages to avoid compatibility issues. So we have lakhs of packages, so every time we need to update our if there is any new update is available, we need to update our version. So if for that we need to regularly update our packages. So difficulty setting up in the R environment and configuring system paths. So as we discussed, it's better to accept the default setup so that the paths will be by default wherever your software is kept. From that the paths will be selected. If you are going for the customized paths, we need to be aware how to set up the path environment for environment variables and follow the installation instructions carefully and ensure that system paths are properly configured. So perform issues due to inadequate hardware or system resources. For example, if we are having the inadequate hardware, in the sense, so we need to update our skeleton or in order to components of that skeleton, so that every time we need to update our hardware as well as software. So ensure that your hardware meets the minimum requirements for running R efficiently. So whether our hardware is updated or not, we need to check that. So at least we need to provide the minimum requirements to inadequate with the or cooperating or supporting with the high-end operating systems, because R is a statistical computing tool. So avoid running other resource intensive programs simultaneously with R. So some of the Sun or MAT labs, so those are the softwares that performs more complex objects. So whenever we are having R software in our system, it's better to avoid Sun related softwares so that the system can be work smoothly. So these are the common issues we face whenever we wanted to install R. So there are some common issues that can be troubleshoot. So for example, whenever we get an error like cannot allocate vector of size, so whenever you are getting an error like this, increase the memory limit for R by using the memory dot limit. So whenever we are working on R programming, at the time we get an error like this cannot allocate vector of size, then we need to change our R programming environment memory by using this function, the memory dot limit. So in that limit we will give the argument. That argument can increase our memory allocation for R, and package is not available for our version. So in order to, if we get an error like this, as we discussed earlier, we have a package window. So from that package window we can plug in whatever the package we want. So we can download and we need to install that missing package. So if you are getting an error like is not a valid Windows 32 application, then solution is install the appropriate version 32 or 60-bit version of R and any required packages. So these are the common errors we used to get, and if you get an error like this, we need to follow this solution. Now so far we installed the R and we have discussed some common issues. Now we are going to see R sessions, how R sessions will be done. So R sessions will be done basically in two ways. One is interactive, another one is batch mode. So in interactive mode, we will use some of the functions from the input functions. Those input functions will take the input from the user, like read line, scan. So those are the functions. They can access the keyboard and monitor. These two functions can accept input from the user. So by using them in interactive session, prompt the user for input as data or commands. So the user can the computer can take the input from the user either by the lines or by the commands. So typically an interactive session, there is a software running on a computer environment and accepts input from human. So basically we have two types of input functions, that is read line second one is scan. So these two are the input functions. So there are different arguments can be accepted, these two. So here we have said all data and commands are pre-selected through scripts. So if you are using any scripts or if you are using any files, through that files we need to give the instruction, then we will use the scan. So this scan will take the text, okay, as an argument, whereas read line it will take the scalar as the input. Okay, if suppose if it is a character type, then it will be accept. If it is a numer, then we need to use the as stat integer. So by default, whatever the argument we have taken, that will be considered as the character only. If suppose if we want to convert it into the integer, then we need to use the as dot integer, or it is the batch. Scan will take if it is character, it will be character, or if it is anything, it will be considered as character only for the read line. So that we will use the as dot integer or as dot numeric. So the input whatever we have given, that will be converted into the data type we want. So these are the things that can be happened with this interactive mode. So this is the simplest way to work on a system. You simply log on and run whatever the commands you need to do, whether on the command line or in the graphical environment, and log out when you are finished. So an interactive mode, where from where the user sits on the system, he will execute. So this is about an interactive mode. And the second one will be the batch mode. So in this batch processing, in interactive session, what it happens, once we log into the system, we will be interacted with the operating system where the software lies. So by using the input functions or by accessing the keyboard and monitor. But in the batch processing, what it happens in the sense, batch processing is the execution of series of programs or only one task on a computer environment without manual interaction. So without the intervention of the human, the operations can be done, the programs can be given arranged in a series, and those series of programs can be given to the environment, and it will access all the programs without intervention of the user. So this kind of processing is batch processing. All data and commands are pre-selected through the scripts. So whatever the operations we are going to perform, those are already kept in the scripts. So it can be the commands or whatever the operations we want to perform, those are already written in the programs. So that can be done through scripts or command line parameter, and therefore run to completion without human contact. So we will give entire program, entire things will be programmed. So that program will take care of what are the commands or what are the operations that has to be performed. So this is termed as batch processing or batch mode, because the input data are collected into the batches of files and processed in batches by the program. So why we are calling this batch processing or batch mode, in the sense, here there is no intervention of the user, and second thing, so whatever the operations that can be performed or whatever the inputs it received, all this will be received through the batch. So batch processing, so all these things will be kept in a file and that file can be executed. So in many cases, batch jobs are submitted to a job scheduler and run on the first available compute nodes. So we will schedule, so number of batches will be, the batch files will be given to the batch scheduler. This scheduler will arrange which batch or which schedule, which one will execute the first. Based upon there are a number of schedule algorithms. Based on that, each batch will take in its execution time. So all will be executed. So this is about batch processing mode. There are two types of R sessions. One is interactive, one is batch. When it comes to the interactive, so there the user will be involved. He interacts with the system and he will give the input and he will get the output. So when next one is batch mode. In the batch processing, so the user will not involve. So whatever the operations we want to perform, all these things will be programmed. So these programs will take care of what kind of inputs it has to give and what kind of outputs it has to get. So without the involvement of the user, the program itself it takes care of what it's supposed to do. So these are the two modes of R programming. So here we have written the first R program. So so far we haven't written any program, so that I have written a program here. So for that I have taken this quicksort. So here I have written a program. So this program is for quicksort. We know that quicksort is nothing but which is having the best time complexity algorithm. So in quicksort, what it will happen in the sense, whatever the list we have given to it, it will sort out that list and it will give the list with the sorting order. There are a number of sorting algorithms, but why we have taken quicksort, in the sense it has best time complexity of order of n into log n. So this is the way to define the function. So far we haven't written any program. So I'm explaining each and instruction and why we have written. So for the first thing, this is the way how we are defining a function. So whenever in R programming, if we want to write a function, first we have to use a keyword of function. So this function is the keyword. So this function is a keyword. By using this, we will create a function. Now I am creating a function that is quicksort. So this here quicksort is the function. So this is the actual argument. So it will receive the values from this here. Once the function calls, from here we will get the values here. So far we have created a function called quicksort with the keyword function. So in that we have written the body. So all this is body of this program. Okay, first we will see how a quicksort will work. For example, if we are taking 4 elements, what we first will do is, in quicksort we will find the pivot value of this. So first we will find out what are the elements that are available. So we will find the middle of this element, and based on this middle of the element we check all the elements of the left side are is less than or greater than of this value. If these elements are less than this value, then we will keep them in the left side. If the elements are greater than this pivot value, then we will keep them in the right side. Okay, for this set again we will find the pivot value. For this set we will find the pivot value. Like this we will do, and we will identify, we will keep the elements in a sorting order. This is how a quicksort will work. So that what we do here. So if suppose if we have taken a list, if that list is less than or equal to 1, then we will return the X. So if the list contains only one element, then that will be in the sorting order only. If not, we will check the pivot and we will assign to 1, and the rest will be the X minus 1. So here choosing the pivot is your choice. Here I am taking the first element as the pivot element. Okay, I am not taking the middle. So choosing pivot is your choice. Okay, and I am taking the last element. So in order to get the last element, we use this X of minus 1. So it indicates the last position of that list. So here the list is X. So I have assigned X is minus 1. So from this the last element will be the 5. So in order to indicate the last position of that list, I have taken minus 1. So the negative index will represent the last position of the list. So I am taking the pivot will be the first element, the next element, the up to last I have considered the rest. So I have taken variables sv1 and sv2. So I have taken the elements, the rest less than pivot will be kept in sv1, the rest is greater than pivot will be kept in the second variable of sv2. So the next sv1, the rest I have written the elements 2 times. Okay, so I will be kept in this. So here qs is the so it is a what is called recursive function. I have applied on this qs and qs2. So whenever we are applying the recursive function, the function can be called itself repeatedly. So in order to get the pivot, so if it is greater than 2, it will be fine here. If suppose here I am having 11, so it will, if it is the pivot, it need to check this, we need to check this, we need to check this. So all these iterations has to be done. So in order to do that, I am taking this functions as the recursive functions. So what it happens is, and it will be returned unless until the respective elements reach its respective position. So whatever the element that is greatest element among the listing, then it will reach the last position. For that it need to take a number of iterations. For that I am taking the quick sort of this. This SV1 will have the elements that are less than pivot. This SV2 will have the elements that are greater than pivot values. So for each iteration one element will be sorted. So after that we will return SV1, pivot2 and SV2. So finally it will get the elements less than pivot will be stored in the SV1 and pivot will be stored, and greater than pivot value will be stored in the SV2 variable. So these are the three arguments will be written. So at the last we have given the x. We need to pass the values for x. That's why we have given the formal parameters here. These formal parameters will be received by the actual parameter. So now x will receive these elements 23, 5, 44, 65, 22, 12 and 7. So for this, for the first iteration, 23 will be the pivot and the rest will be, the remaining elements will be stored in the SV2. So it will check if 23 is less than 5. No, 23 is actually greater than 5. So this this 5 will stored in the SV1. So this is for one step. Now 5 will be in the first step, 23 will be in the SV2. Again this PV5 will be checked with the remaining elements, whether this 5 is less than 44, okay, less than 65, okay, 22, 12, 7, it is okay. But the next element will be the 23, right? This 23 will be if it is greater than 44, then it will be kept in the SV2. If it is less than, it will be kept in SV1. So like this, for every one complete iteration, the one element will be sorted. So it will be done like this. So once the all elements are sorted, it will comes out of the recursive function and it will gives the element, it will return the elements and it will return at the end the elements will be sorted like this. 5, 7, 12, 22, 23, 44, 65 will be sorted out. So here again the pivot will be the 5, the remaining elements are all these. So once the elements will be sorted, it can be printed out. So this is the first R program. We can also write hello world, like simply print hello world. So it doesn't require any header files or it doesn't require any output functions, etc. If it is an character, that's why I have used this. If suppose if you are storing in a variable like x, then you need not to give an output function also. Simply giving an element is enough to display the output. So this is an sample program for from R. So this is the first R program. So in the next session we will discuss about the data types and the data structure in R.